Hello, good day viewers. In this tutorial, we are going to talk about the conjugate of a complex number. We have some problems to treat in this tutorial. You can see them down here. But first of all, let us understand what it means by this conjugate of a complex number. Remember last year when we treated surds, we have seen that if we multiply a surd by its conjugate, it gives rise to a rational number because surd is an irrational number. So the same thing here, if you multiply a complex number by its conjugate, it gives rise to a real number. You know, in surd, it gives rise to a rational number, but this time around, real number. Remember, how do we write a complex number? Z equal to A plus BI. This is a complex number where A and B are all real numbers and I is the imaginary number. So the complex of Z, which is denoted by this, is equal to A minus BI. The only difference between them is the sign in between them. If you are given this and you're asked to find its conjugate, it is exactly equal to this one. And if this is what is given to you, this is said to be the conjugate. They only have a difference of sign. If this is plus, you consider the negative one as its conjugate. So let's confirm whether that statement is true. If we multiply a complex number by its conjugate, the result is just a real number. Okay? So we want to multiply Z by Z bar, which is the same thing as A plus BI multiplied by A minus BI. So let's distribute. We have A multiplied by the whole of A minus BI. Then we add BI multiplied by the whole of A minus BI. So let me expand. To the left hand side, we have A times A. This is A squared minus A times BI is ABI. Then moving on to the other side, we have plus BI times A is ABI, right? This is ABI. And lastly, we have minus B times B is B squared. Then I times I is I squared. But what is I squared? Remember from definition of imaginary number, we say it is just the square root of negative 1, right? Negative 1. So what if we square both sides? We square this. Negative 1 equal to I squared. It implies that I squared is just equal to negative 1. So if we should replace this with negative 1 multiplied by B squared, already we have another negative here, which is going to transform it into a positive number. So if you observe, this will cancel this because one is positive and the other one is negative. So if we simplify, we have A squared, then plus the last term, which is just B squared. And you can see both A and B are real numbers. Therefore, the whole of this is a real number. So a complex number, if multiplied by its conjugate, the result is just a real number. So let's go through these questions. We have some questions here. 1, 2, I think 12, right? So let's get started. We have 2 plus the square root of negative 9 divided by 4. Let me first of all split the fraction as 2 divided by 4. Then plus the square root of negative 9 also divided by 4. And you know the square root of negative 9 is just 3i. So the only difference between this complex number and its conjugate is this sign in between them. So we have minus instead of plus, right? So 2 over 4 is 1 over 2. Then minus 3i divided by 4. And we are done with this question. Number 2, 5 minus 7i, we have 5 plus 7i. The number 3, we have only the imaginary part, meaning the real part is 0. This is the same thing as 0 plus 8i, right? And the conjugate will be 0 minus 8i. Therefore, 0 minus 8i is the same thing as negative 8i. So negative 8i is the conjugate. Number 4, 7 multiplied by 3 plus 6i. Let's expand. We have 7 times 3, 21, plus 6 times 7 is 42i. The conjugate will be 21 minus 42i. Then here we have only the real part, meaning the imaginary part is 0. So what will be the conjugate? It will be square root of 11 minus 0i. But this is also the same thing as square root of 11. So the conjugate will be square root of 11. You can see that when the imaginary part is absent, both the complex number and its conjugate are all the same. So moving on to question number 6, you know, this can be split as 1 divided by 3 minus I divided by 3. Therefore, the conjugate will be 1 divided by 3 plus I divided by 3. Number 7, the real part is absent. All you have to do is to negate this to positive. We have I over 5. Number 8, we have the imaginary part before the real part. So let us arrange it as negative 4 minus I. Therefore, the conjugate will be negative 4 plus I. Number 9, we have negative 2 multiplied by square root of negative 2 plus 10. Let me rearrange it as 10 minus 2 root of negative 2. Root of negative 2 is just root of 2i. So the conjugate will be plus here instead of minus. So we have 10 plus 2 root of 2 then I. We are done with this part. Moving on to the other part, 10 to 12. Question number 10 is stated that if a complex number is the same thing as its conjugate, then the imaginary part of the complex number z is 0. We have treated this one in question number 5. Look at it here. You see, we have the complex number just root 11 and the conjugate is also root 11. So when the imaginary part is 0, that is when you have a complex number equal to its conjugate. Or should we prove it? Let's prove it here. Suppose I have z equal to a plus bi. The conjugate will be equal to a minus bi. So what does this mean? It means if we should equate z and its conjugate, which is the same thing as saying a plus bi equal to a minus bi, a's will cancel, right? This implies that bi is equal to negative bi. I will cancel, b equal to negative b. How is this possible? It is only possible if b is equal to 0. This is the only condition. And if b is equal to 0 multiplied by I, everything will be 0. Okay, we are done with that one. Then 11 is stated that if z is equal to negative 1 minus square root of negative 1, then the conjugate is what? So this is negative 1 minus I, because the square root of negative 1 is just I. So the conjugate will be what? Negative 1 plus I, which is option B here. Then the last question, we are given a conjugate as I. Then the conjugate of a conjugate plus the complex number is what? That is the question. Let me do it down here. We are given the conjugate as I. Then if you reconjugate it, conjugate of the conjugate will give us negative I. And remember that conjugate of a conjugate is equal to the complex number. Let me do it down here before I come back. If z is equal to a plus bi, right? The conjugate will be a minus bi. What if you take the conjugate of this? You have conjugate of conjugate equal to a plus bi, which is exactly the same thing as our complex number. So this one is also equal to the complex number. So the question is saying, what if we should add the conjugate of the conjugate plus the complex number? It is the same thing as taking negative I, you add it to another negative I, which is just negative 2i. And this is our answer, which is option D right here. And this is all I have for you today. Thank you for watching. Do share to your learning colleagues and don't forget to subscribe to my YouTube channel for more exciting videos. Bye bye.